Okay, so now I'm going to take on another type of variation, which is the one that is called inverse direction, variation. So the second one is inverse variation. Okay, so subtopic is inverse variation. That's the subtopic. Okay, now here's how it is said generally. I'm going to use X and Y. You can say that Y varies inversely as X. Or you can say Y is inversely proportional to X. These two statements are exactly the same thing. They mean exactly the same thing. All right? So now, once you hear such a statement anywhere in mathematics, in science, in technology, once you hear this type of statement, the next thing you will do is bring it up into a mathematical symbol. In that case, you will just write y is proportional to 1 over x. 1 is proportional, inversely proportional to 1 over to x. You see, in the direct variation, the x is on the numerator. In the inverse direction, the x is on the denominator. That's the huge difference right there. Okay, so now we can say that this follows that y is equal to the constant divided by x. This is an inverse variation right there. That's an inverse variation right there. Okay. Okay, so now how does this apply? How does it apply? Now, let me give you a general situation how it applies. If you have a graph, that looks like this, whenever you plot a graph that looks like this is your x-axis, this is your y-axis, and then you see your straight line running this direction. Okay, so that means, what this thing means is that as y increases, x decreases. You see, this is our line L1, and in this type of graph you are going to have a negative slope. Okay, so you can say that as y increases, x decreases. Or you can say that as x increases, y decreases. So something is decreasing with respect to the other. So this is inverse direction, inverse variation. On the other hand, if your graph looks like this, this will be a direct variation. As one quantity is increasing, the other quantity is also increasing at the same time. Direct variation. Okay, so now let's look at real life example. Everybody pay attention. I'm just going to read this example. I'm just going to read it. I cannot write it, all of them. So now pay attention. A company has found that the demand for one of the products varies inversely as the price of the product. I read again. A company has found that the demand of one of its products varies inversely as the price of the product. When the price is $6.25, the demand is 40 units. Approximate the demand when the price is $5.75. Okay, so now let me try to write down the variation itself. It says that the demand for one product varies as its product, varies inversely as its price. So demand, D, is inversely proportional to, it follows that demand is equal to K over P. So now it says that when the price is $6.25, which means P is equal to 6.25, that's the price. D is equal to 400 units. 400 units. So this is people demand. You went to the store to buy, let's say, what do I use for example? Just give me one item you usually buy in a store.
Eggs.
Eggs, good. So you went to the store to buy a pack of eggs. Now, by the time you go to the store, the price is $6.25 a pack. Same pack, same number of eggs in one pack. And each time the price was this amount, people bought 400 units of the same product. You see? So now the question is, what would be the demand or what would be the price when the price of the item changed? So what would be the demand when the price of the item changed? Because the price can change. If the price drops to, let's say, $5, do you think that more people, more units of eggs will be sold? Yes or no?
Yes.
Yes.
Yes. You see, that's economics right there. It's called economics. Now, if the price is higher, like $10 per pack, you will find out that people will buy less quantity of eggs just because of the price. That's the way it is, real life. So now, having written that, so let's find the value of K. Let's find the proportionality constant, which is K. So all we need to do would be, we just say that D, which is 400, we just plug in the numbers, plug in this into this equation. We just say 400 units is equal to K over the price is $6.25. So then if we cross multiply, it means that 400 multiplied by 6.25 is equal to the K. So punching the number very quickly, let's find out, please. Use your calculator.
2,500.
Okay, 2,500 is the K. All right, now the question is, approximate the demand when the price is $5.75. So approximate, you can say find or determine demand when price is $5.75. When price is $5.75, this is in dollars. When price is $5.75. So approximate the demand. So in that case, all we need to do is we just come back to our equation, and then it says approximate demand. So we just say demand will be K is 2,500 divided by price is 5.75. So quickly divide that and let us know. 2,500 divided by 5.75 is?
It says 434.78.
Okay, 434.78. Okay, so you can say.
I have a question.
Yes, so hold on a second. You can say that approximately, the demand will be 434.5 units will be sold. Yeah, go ahead with your question.
How come we just don't multiply the 575 times 400?
How come I didn't multiply what?
The 575 times 400.
No, you cannot multiply it because you want to find the value of k. Remember, here's your equation again. Let me rewrite the equation. Here's the equation for this direct variation. The equation is D is equal to K over P, because demand is inversely proportional to the price. So now if your demand is given, which is 400, originally given to us, and that would be equal to K. We don't know K. We want to determine K. And then the price is, the original price when 400 units were sold is 6.25. So all you can do would be to cross multiply in order to get K. That's the only option mathematically possible. Once you have your K, which is this. So going forward, in this particular problem, anywhere you see K, you plug in 2,500. So, and that's what we did here. So remember that equation is still D equal to K over P. And K has already been determined to be 2,500. And the new price now is $5.75. You see, you guys told me that right now, you just told me that when the price is lower, there are possibilities of selling more. And that usually happens in every store. See, once the price is lowered, more items are sold. That's actually the reason for lowering price, so that the stores will get rid of the items. Yeah, somebody else wanted to say something. I say, hold on, who else? Does that answer the question?
Yes, thank you.
Okay, thank you. So now that's inverse variation we just treated right now. That's inverse variation.